Good morning, students. In today's lecture, we will talk about some other important chemical reactions of alkenes. We know it very well that alkanes exhibit electrophilic addition reaction. That is the most important reaction of alkenes. Apart from this, alkanes also exhibit some other type of reactions. And the most important reactions in this type are number 1, ozonolysis, number 2, hydroboration oxidation, number 3, hydroxylation, and number 4 is polymerization. Now, let's start with ozonolysis. If we break this word, then we will obtain two terms, ozono plus lysis. Ozono stands for ozone and lysis stands for breaking down. So breaking down of alkene in presence of ozone is called ozonolysis. An important reaction of alkene. So here what you have to remember? Alkenes on ozonolysis gets converted to two molecules of carbonyl compounds. Now, what are carbonyl compounds? Aldehydes and ketones are called carbonyl compounds. So, product that you will obtain may have two molecules of aldehyde or one molecule of aldehyde and second is your molecule of ketone, or it is also possible that you will obtain two molecules of ketone. So what type of products will be formed is decided by the structure of alkene. If the olefinic carbon atom contains branching, then that part on ozonolysis will always form ketone. So here is your ozonolysis reaction. The most important unit is olefinic bond or double bond. Ozone molecule will be added on the olefinic carbon atom. So when ozone molecule is added over olefinic carbon atom, then we obtain a cyclic intermediate which is called ozonite. 3 atoms are added in this manner. When O3 is added, then double bond between the carbon atom is removed. So here is your cyclic intermediate, that is your ozonite. Now ozonite, when treated with Zn plus H2O, undergoes Y-type cleavage. So here is your Y-type cleavage. This oxygen will be removed and the bond cleavage will take place between the O atom and two fragments will be separated in the form of two products. So this part will form C double bond O, this part will also form C double bond O. So every time the double bond is important. So here you have to remember one thing. Whenever we want to get the product of ozonolysis, then do one thing. Just cleave this bond so that this part and this part will be separated. After that, attach oxygen on both fragments. So it will be C double bond O, it will be C double bond O. So let us see example of ethene. CH2 double bond CH2 is the representation of ethene. But we have to represent the molecule in this manner so that we can form ozonite, we can show attack of O3, and after that we can show the cleavage, Y-type cleavage. So here is your C double bond C, H and H, H and H and O3. So O3 will be added over the olefinic carbon, as a result of which you will obtain ozonide of ethene. Now this ozonide, when treated with 100% H2O, undergoes Y-type cleavage. So here is your Y-type cleavage. This O is removed. Here cleavage is there between O. So both the units will be separated and both will be converted to methanol and methanol. So the product formed is decided by the structure of the alkene. If the products are given for the ozolysis, then you can deduce the structure of alkene. Then we have next one, that is your hydrobolation oxidation reaction. Again, an important reaction. By this reaction, alkenes will be converted to alcohol. By this reaction, alkenes will be converted to alcohol. Now, about hydrobolation oxidation. The reaction gets complete in two steps. Step first is called your hydrobolation, and step second is called your oxidation. Now what happens in hydrobolation? Hydrobolation, hydro for H, boro for boron, boronation for boron. So in this reaction we will add H and boron atom to the alkene molecule. So what will we use? We will use BH3. Remember, BH3 does not exist in nature, not stable. The stable one is B2SX. But to write the reaction in simplest way, simplest manner, we are converting B2SX to BH3. So 3 molecules of propene and 1 molecule of BH3, boron, will react, as a result of which propene will be converted to tripropyl boron. There will be 3 propyl units. Each propyl unit is bonded to boron atom. Now, in next step, we will carry out oxidation for tripropyl boron, and it takes place in presence of alkaline H2O2, hydrogen peroxide. Remember, H2O2 can act as oxidizing agent. So what happens? This boron is removed in the form of H3BO3, boric acid, and the remaining part gets converted to alcohol. Here you will obtain propanol. The addition of water takes place according to anti-Markovnikov's rule. If we want to convert alkene to alcohol, and if we are using concentrated H2SO4, means we are using acidic hydration, then by that reaction we will get alcohol, and addition of water follows Markovnikov's rule. But here it is anti-Markovnikov's rule. Then we have number 3, hydroxylation. We will add OH group, and for adding OH group we are using aqueous KMnO4. So when ethene is treated with aqueous KMnO4, it undergoes hydroxylation, as a result of which we obtain vicinal diols. Diols where 2 OH are there. Vicinal diols means 2 OH will be there on neighboring carbon atom. So ethene gets converted to ethane 1,2 diol, which is also called glycol by common name. So whenever aqueous KMnO4 is there with alkene, then alkene will be converted to vicinal diols. Now the last one is your polymerization or polymerization. In this reaction, small molecules which are called monomers gets converted to a large molecule which is called polymer, where repetition of small molecules will be there. So when monomer gets converted to polymer, then the reaction is called polymerization. And here, if we take n molecules of ethene, this n can be more than 100, it can be 1000 also. So this is the simplest unit, this is the monomeric unit. Will be repeated n times, as a result of which we will obtain a large molecule which is called polymer. So ethene, in presence of suitable catalyst, undergoes polymerization and gets converted to polyethene. So CH2 single bond CH2 unit repeated n times. Whenever polymer is there, then we write or we use subscript n. N represents this unit repeated n times. It contains more than 100, more than 1000 molecules. So it's all about the chemical reactions of alkene. In next lecture, we will talk about alkyne. Thank you. Have a great day.